The Most Annoying Equation Conversion is an episode of the Degrees of Freedom Project videos on chemical and thermal principles. Definitions and additional details can be found in the webpage link in the description. This video, The Most Annoying Equation Conversion, explains how to convert an equation that has variables in one set of units into an equation with the variables in a different set of units. The first video in the conversion series, Is Furlongs per Fortnight a Thing?, explains how to convert a measured or calculated quantity from one set of units to another for most everything except for temperatures. The second video, How Keen is Your Rank?, explains how to convert temperatures. Look at the links in the description or on the website for the other videos in the series. Let's say you found online an empirical equation for the enthalpy of nitrogen. The enthalpy is 1.04 times T minus 26, where the specific enthalpy is in kilojoules per kilogram, and the T is in degrees Celsius. You're doing work for a company that always uses gas enthalpies in BTU per pound mole, and temperature in degrees Fahrenheit. How do you transform your equation into such an equation? There are lots of methods that won't work and several that will. The following method always works as long as you can do simple math correctly. 1. Start with the variable in the target units, in our case, BTU per pound mole in degrees Fahrenheit. 2. Convert them using dimensional equations and/or temperature equations to the original units, in our case, kilojoules per kilogram and degrees Celsius. 3. Plug in the converted expressions into the original equation. 4. Simplify. Let's apply our method. We'll start with two new variables, lowercase h hat in BTU per pound mole and lowercase t in degrees Fahrenheit. Next, we convert lowercase h hat to kilojoules per kilogram using a dimensional equation and t to degrees C with a temperature conversion. First, h hat with a dimensional equation, then t with a temperature formula. We'll then plug the complete expressions into the original equation in place of the original variables. We put lowercase t minus 32 times 5/9 in place of uppercase t. We put 0.08297 lowercase h hat in place of uppercase h hat. We then simplify. We take the substituted equation and multiply out the 5/9. We then multiply out the 1.04 and divide through by the 0.08297. Completing the math gives us our final equation where the specific molar enthalpy of nitrogen is in BTU per pound moles, and the temperature is in degrees Fahrenheit. You can verify the procedure by calculating a few values of enthalpy for values of T with the original equation, converting the values to BTU per pound mole in degrees Fahrenheit, and compare with what you get for the converted equation. If you don't follow this method, you are almost guaranteed to get things inverted or just plain wrong. Let's do one more example. Wikipedia discusses an equation for calculating the vapor pressure of a species as a function of temperature. The equation is known as the Antoine equation. The version in Wikipedia is the log base 10 of the vapor pressure is equal to A minus B over T plus C, with the vapor pressure in millimeters of mercury and the temperature in degrees Celsius. Other references use a form of the Antoine equation with the natural log of the vapor pressure equal to the same function, but now with the vapor pressure in kilopascals and the temperature in Kelvin. What is the relationship between big A and little a, big B and little b, and big C and little c? Start with the variables in the target units, natural log of psat in kilopascals and T in Kelvin. Convert them to the original units. We convert psat to millimeters of mercury with a dimensional equation, and convert natural log to log base 10 by multiplying by log base 10 of E. We subtract 273.15 from the T in Kelvin to get T in degrees Celsius. We then plug the converted expression into the original equation. We replace log 10 of p star with the expression shown and replace capital T with the lowercase t expression. Now, we simplify. First divide through by log 10 of E. Then switch the log of the product to the sum of the logs and multiply through by 1 over log 10 of E. Finally, gather things together. The result is lowercase a is 2.3 times uppercase A minus 2.01. Lowercase b is 2.3 times uppercase B. And lowercase c is uppercase c minus 273.15. If you have a superior way to do the conversion, let me know, because I've never seen one. You should now be able to convert any equation with dimensions into any other set of units. The takeaways. To convert an equation, as opposed to a value or a variable, from one set of units to another set of units, do the following steps. 1. Start with the variables in the target units, the ones you want to end up with. 2. Convert your target unit variables to the original units with dimensional equations and/or temperature conversions. Don't forget the difference between temperatures and temperature intervals. They get converted differently. 3. Plug the converted variables into the original equations. 4. Do the arithmetic and algebraic simplifications. Thanks for watching. This video was brought to you by the DOFPro team.